Hello everyone, my name is Chung On. Today I'm presenting for JAC 444 Workshop 10. So in the first task, we have the module on playing with matrices. And we try to compare sequential multiplication and parallel multiplication using 4 threads. So to save time, I must run the main first because sequential multiplication is gonna take way more time than parallel multiplication. So I start first. Obviously, parallel matrix multiplication is even faster than I say it. And while we are waiting, let's talk about what happens here. We initialize matrices and we use the main function called start matrix to generate matrices. And in the main, we are just showing the output and calculating the multiplication time in milliseconds. So this is the traditional way of doing a matrix, and we just use randomized integers for the process. And in parallel multiply matrix, we have the executor using 4 threads, and the executor takes care of the using another. Okay, this is done. Using another function called parallel multiply. So the moment I said it, it's also done. So obviously sequential is far lower, like 1,000 times slower. Anyway, back to the code. In parallel multiply matrix, we are using the executor that calls another function, which is this one. So here we have the local constructor of the matrices and local results and local rows. And in the run function, after we calculate each pair of matrices, we reset the results because otherwise we are gonna get a stack overflow. So we only care about the runtime, like here. So we don't need the multiplication results. And in the sequential, of course, we are just using the traditional way. So local matrix and the main adding of the results. So that's why the runtime is about there's a huge difference in the runtime. Okay, so the next one we are talking about the dynamic philosophers, and here we have 5 guys, and they have left and right chopstick on their side, and when they try to pick up any chopstick, then they are gonna be competing with the other guys. So that's why in adopting solution 2, instead of having a waiter in solution 1, we are using multi-threading, and essentially to avoid a deadlock, the compromise, can I say, is that they take turns basically. We are not gonna have 5 philosophers eating at the same time because of limited chopsticks, and we have separate classes for chopstick and philosopher. In the chopstick class, we just have the 2 synchronized method where we have wait and notify. So it is about how the philosophers wait and take turns essentially to pick up both chopsticks to eat. And for put down, it is just about saying that they finish eating, so they have so they give the chance to the others in a way. In the philosopher class, we have a constructor on how we call the philosopher. Just instead of using actual philosopher names, we are just gonna use 1 to 5 for simplicity. And both chopsticks and randomized food item, but that's randomized in the main function. So it's mainly about through multi-threading in chopstick, we are gonna see if a philosopher picks up the left first or the right first, and also whether they put down the left or the right. But the main thing is they pick up the chopsticks and then they will eat. So the put down doesn't matter. And we also need to have a print function to see who starts, who eats, and who finishes. In the main, we have the randomized food items. This time we have Italian cuisine, and we initialize chopstick objects and philosopher objects and food, obviously. And to avoid a deadlock, I have a very short, brief sleep functional going on. And we can ask the user if we want to have another round of eating. So to test this, this is faster than I say it. At first, they are thinking, and we already see that it doesn't have to be 1, 2, 3, 4, 5. It can be in a different order. And obviously, number 4 starts first. But number 4 eats only after number 2 does. And number 2 is done first. Then we have the other guys. And even though number 5 is the latest to have the chopsticks, and of course number 5 also eats, but number 5 finishes faster than number 3, so this is faster than I say it. And if you want to have another round, we can press Y. We have another round. Instead of torta caprese, we have lampredotto. Okay, this time it's 1, 2, 3, 4, 5. 1 goes first, and 3 finishes last again. We have another round. This time we have panino. Number 1 starts first. Number 4 finishes last. We can have any round. Risotto, lampredotto again, parmigiana. Oh, it seems like number 3 seems to finish. Okay, now this is number 2 being the last to finish. Thank you for watching.